My source battery is pretty low. It's at 10.64 volts. It is this battery. The circuit is a single BD243C, wired up as a solid-state DC oscillator. This is the adjustable pot on R1, which is the base resistance that's adjustable. It's 526 Litz wire here, which is air core currently. I have the EI core for it, but if I put that in, the overall frequency drops to under 1,000 hertz, down from about 30 to 40,000 hertz. Here's the EI part of it. There's another half of this, looks exact same, slides up the middle. But that is not used because I want that 40 kilohertz roughly, which drops to about 30 kilohertz once it's running. So as noted, you see it's at 10.64. We will disconnect the light on the output, and we will connect up this to the ammeter to start the oscillation. So it's at 9.58 current, about 300 milliamps. Now I'm going to attach this LED light bulb to one of the windings coming out. So there's the current that's currently there, and there it is with the LED lamp. Dropped about 100 milliamps. Input volts 9.62, about 200 milliamps, and we have the full light output. It's a 3-watt LED. So that's it. This shows the DC charged, which actually charged up anyway. It's not connected or shorted to any of the other two windings. It's connected one end to either end, out through a bridge rectifier and into this cap, and it's charged up to 60 volts on its own. Not being connected. And if I connect it, it actually starts dropping. Huh. Curious. Anyway, so the main thing to show though was that with the LED light disconnected, that's the input. When it's loaded, that's the input. It drops. So, a couple of things next up. We need to check out what happens if we try and put just a bridge rectifier off of a single winding and directly into a battery for a constant load, in addition to the LED lamp being lit at the same time from the oscillator, and see how that works in terms of the current draw and the voltage usage from the battery. And then we'll see where to go from there. The next step will be just to try and build circuits to make it the most efficient possible, as well as to prevent battery usage during the day when solar panel can suffice in driving the oscillator, which will then be driving the lamp. So it's not bad for about 300 milliamps at about 12 volts if that battery is fully charged. So we'll have to charge that up and start up the sequence of experiments again. Anyway, that's it. A lot of extra crap on there that you don't need. I mean, the only thing that's really needed is this transistor, a couple of resistors, and the pot. The ammeter and the scope are on that little circuit, and the output's just one of the 526 wire Litz windings that's coming out. So only 3 windings out of the total of 5 windings are in use, 2 for the oscillator and 1 for the collection that's going to the LED lamp. The other 2 will then be able to be used to charge capacitors, to charge a battery, or to recharge the battery. The idea being that during the day, all charge would be coming from solar panel to charge both the battery and run the light. And at night, the charge would go from the battery to the light. So every day the cycle would repeat so that it charges the battery during the day, and at night the battery is used for the light, and the next day it charges again, that kind of thing. So it's just all about sizing the system properly. Anyway, that's it. A simple little oscillator. This is a Bedini type circuit. But I mean, being that it's just a single transistor DC oscillator, it's pretty hard to patent it and all the different uses, and especially once you start adding the other circuitry around it, the control circuitry for preventing the battery from lighting the light during the day, as well as then the passive discharge circuitry that will drive both the light and the discharger to charge the battery. Those additional components all weaving together into a single thing become a single application, which you can then call unique and patent. So, although I'm not really looking for patenting, I'm looking to actually prove concept, make something useful that's sized appropriately to be effective for a continual use basis. Anyway, so that's it. We'll disconnect that circuit. I need to charge that battery.